All right, beta. So today we are going to be studying alkenes. ठीक है? Alkenes is the second homologous family that O levels and IGCSE students are familiarized with. ठीक है? In the previous class, we completed the homologous family called alkanes. Alkanes were called saturated hydrocarbons. Alkenes are unsaturated hydrocarbons. ठीक है? And in the previous class, we discussed what is saturated and what is unsaturated. So alkenes are unsaturated hydrocarbons. Unsaturated means anything which contains carbon carbon double bond or carbon carbon triple bond. All right, carbon carbon triple bond is also proof of unsaturation. Okay, what is hydrocarbon? Hydrocarbon are organic compounds made up of hydrogen and carbon only. All right, the general formula of all alkenes is CnH2n. This is for straight chain alkenes, meaning any alkene that is in a straight chain. Okay, सही है. But if the alkene is in a cyclic structure, then this may not work. ठीक है. Hexene, propene, pentene, etc., etc. All right. The physical properties of alkenes or the physical trends of alkenes, the physical characteristic trends of alkenes are the same as the physical characteristic trends of alkanes. ठीक है? That the melting boiling points increase as size increase. ठीक है? Uh, the larger the alkene is, the higher its melting boiling point will be, and more will it be its viscosity. ठीक है? The larger the alkene is in size, the greater will be its viscosity, and similarly flammability, because alkenes are also a homologous family of organic compounds that undergo combustion, which means that they burn in presence of oxygen, right? So because they burn in presence of oxygen, therefore we also talk about their flammability, and flammability of any homologous family which has the ability to burn in presence of oxygen decreases as size increases. All right, so increase in size decreases flammability. All right. uh like alkanes, alkenes are also considered non-polar, meaning that they don't really have any charges. However, unlike alkanes, alkenes are much more active. In question, why alkene react? Answer is very simple. Alkenes are much more reactive than alkenes because of the presence of carbon. Well, the carbon-carbon double bond ensures that alkenes are highly reactive. All right. Now, when we talk about the chemical property includes combustion reaction. All right. Alkenes have undergo combustion reaction or combustion of, and I have explained it in the new notes how combustion reactions of two types in alkanes. ठीक है. So yeah, I believe it was up top in combustion right here. ठीक है. So there are two types of combustion. One is something is burnt in excess, yeah, ample high quantity of oxygen, and it produces carbon dioxide and water. All right, the products of complete combustion are carbon dioxide and water. However, incomplete combustion is when substances are burned in limited, yes, scarcity, a very scarce supply of oxygen, and because of scarce and limited supply of oxygen, carbon monoxide is produced, not carbon dioxide, right? So either carbon dioxide is produced or carbon monoxide is produced. In complete combustion, carbon dioxide is produced, and in incomplete combustion, carbon monoxide is produced. All right, so one of them is mentioned over here. All right, all alkenes, they react with oxygen to produce carbon dioxide and water. It's very simple. All right, you should know how to balance these chemical equations as well. That is also something of importance. All right, so for example, if we have a chemical reaction that goes like C5, let's take C5H10. All right, and let's react it with oxygen, and let's say that this is complete combustion. So CO2 and H2O produces. Okay. So what, how will you balance it? The rule is very simple. Always balance carbon first, then hydrogen, and finally oxygen. This is, if you can remember this, then this will make it easy for you to balance. Okay. So first balance carbons. To balance carbons, you will put a 5 over here. Okay. When you put a 5 over here, all the carbons are balanced. Once all the carbons are balanced, there are now how many hydrogens are there? 10. So you put a 5 over here. Now all the hydrogens are also balanced. Now balance oxygens, 5 twos are 10 and 5 ones are 5. 10 plus 5 is 15. All right. So you want to make 15 over here. To make an odd number, put a fraction. Okay. Always put a fraction. You can put a fraction. It's completely fine. Okay. So 15 upon 2 oxygen is how much will be required. Okay. Next, we have alkenes have higher carbon content than alkanes, therefore they burn with more sootier flame. That is also an important aspect. Alkanes are much better at burning without smoke or soot or ash. Alkenes, as their carbon content has increased, there is a higher carbon content in alkenes than in alkanes, therefore they will burn with greater soot. Okay. On to the next thing, their addition reaction. All right, the alkenes, they undergo a characteristic chemical reaction called addition reaction. All right, addition reaction are those chemical reactions in which the carbon carbon double bond of an alkene breaks and two new substances are joined, one each on the two unsaturated carbons. ठीक है, तो जो unsaturated carbons होते हैं, those carbons, they gain one species, one group of atom or a single atom each. ठीक है, and this double bond breaks. सही है. The result of addition reaction is only a single product. All right, every time addition reaction takes place, only a single product forms. ठीक है, every addition reaction only produces a single type of product. Right? So the addition reactions that are in your syllabus: hydrogen reaction, bromination reaction, and addition polymerization. ठीक है, these are the four types of chemical reactions, four types of addition reactions that are here. Okay, so let's go for the first one, hydration. So hydrogenation. What is hydrogenation? Hydrogenation is the addition of hydrogen onto alkene. All right, it is the addition of hydrogen onto alkene. The reaction requires a few conditions. You need 200 degrees Celsius temperature and you need nickel as catalyst. All right, so these are the two things. Uh, uh, but it is very important. Hydrogenation is a very useful method for making margarine. All right, margarine from butter. All right, so from butter we can make margarine by hydrogenation of butter. All right, why would we want to do that? When we add hydrogens, the overall mass of the compound increases. It becomes from ethene to ethane. The mass is increased by 2, and the mass is increased by 2 per double bond. Now, if there were more carbon-carbon double bonds, more hydrogens could have been hydrogenated onto the molecule, and the greater the mass will be, the greater its melting boiling point will be, and the greater will be the shelf life. So, margarine has a much better shelf life than butter. Then, margarine is also much better in taste, meaning its taste is more palatable. Palatable means के जो taste है वो करने के बाद कुछ लोगों को होता है, एक रिगर्जिटेटिंग फीलिंग होती है, वो नहीं आएगी. ठीक है, बट बटर हैज दैट टेस्ट एंड odor, राइट, which is not pleasing to many. So that is why margarine is quite famous as well. ठीक है, so butter can be converted into margarine by hydrogenation. Example of hydrogenation has been asked previously, therefore this is an important factor to remember. ठीक है, if you look at this reaction closely, the reaction is very simple. ठीक है, uh, what happens is the hydrogen, there are two hydrogens, H2, right? One hydrogen joins one carbon, the other hydrogen joins the other carbon, and this double bond breaks. All right, so because one of the bonds breaks from the double bond, each carbon has now a valency which it can join or use to join with a new hydrogen, separate hydrogen, and this is how the two hydrogens have joined. Okay, you just need 200 degrees Celsius temperature and nickel as catalyst. Now this hydration reaction, the next reaction, hydration reaction. Oh, before hydration reaction, you should also know that the result of hydrogenation is always a corresponding alkane. Meaning, when you had ethene, you will produce ethane. When you had propene, you will produce propane. When you have butene, you will produce butane. Okay, सही है? So that is how it works. Okay, now the next is hydration. What is hydration? Hydration is basically the addition of steam, addition of H2O. Basically means why not water? Because the temperature we are using over here is temperature at which water does not exist as water, it exists as steam, it exists as gas, right? ठीक है, So hydration would be the addition of steam. All right. The temperature required is 300 degrees Celsius. The pressure required is 60 atmosphere pressure, and phosphoric acid is used as a catalyst. All right. You're going to need phosphoric acid as catalyst, 300 degrees Celsius of pressure and 60 atmosphere pressure and 300 degrees Celsius of temperature. Okay. Ethene will automatically react with steam to produce ethanol. So what do we see? We see that alkenes by hydration produce alcohols. Alkenes by hydration produce alcohols. ठीक है? Alcohols is also a homologous family which you will study after this chapter, after alkenes. ठीक है? After alkenes you will study alcohols. ठीक है? So how does that happen? Basically, steam is water at high temperature. So water's formula is H and OH, right? ठीक है? H2O or H and OH. Now the H will join with one carbon, the OH joins with the other carbon. It is that simple. Okay. So this is the complete addition reaction of steam onto an alkene and it produces alcohol. This reaction is very famous in Le Chatelier principle as well. This reaction is very famous in Le Chatelier principle as well, because you can see that it is a reversible reaction, right? So conditions, they are, we're changing the conditions, what will happen then, what will happen now, will happen here. So those things, because of those changes in condition, this chapter is also famous over there in reversible reaction. ठीक है? अच्छा. One more thing is that this method produces alcohol. Now, on the basis of general knowledge as well, we know that alcohol is not produced on large scale using this reaction. It is usually produced by another reaction called fermentation. So why is fermentation used and why is this method not used? Or in other words, what are the advantages of using this method and what are the advantages of using fermentation? All right. So fermentation is a method by which alcohol can be produced as well. All right. What is the benefit is that fermentation does not require these high temperatures or high pressures or catalysts. Therefore, fermentations don't have a lot of running cost. This is a running cost, right? Because these are things that expand every time, right? Every time you're trying to produce alcohol, you have to give 300 degrees Celsius temperature, you have to give 60 atmosphere pressure. These are expensive conditions, all right? But fermentation does not require that. Fermentation occurs at room temperature and pressure. Okay, so that is why fermentation is more beneficial and more utilized. However, what is the benefit of this over fermentation? Uh, you can write this down as well. Hydration of alkenes produces pure alcohol. Alcohol is relatively pure. Okay, it is of high purity. The alcohol produced by hydration of alkenes is of high purity. Okay? Whereas the alcohol produced by fermentation is of low purity. It is mixed with gases, it is mixed with water, okay? It is diluted. So there are a lot of things that are hindering over there. Okay? So that is a benefit of hydration reaction, that it produces pure uh, supply of alcohol, and it is a continuous process as well. Continuously keep producing alcohol as well if you want to. Now the next reaction is bromination. This is a characteristic reaction, a very important reaction that you need to remember, because it's not only a reaction but it is also a chemical test. All right. What is bromination? Bromination involves the addition of bromine onto alkenes. All right. So alkenes, they react with bromines and they produce bromoethane. And to be more precise, they produce dibromoethane. What do they produce? They produce dibromoethane. All right. So two bromines join or attach onto the molecule of an alkane. All right. So for example, this ethene molecule, when it reacts with bromine, one bromine joins to this carbon, the other bromine joins to this carbon. You just don't even need to heat it much. This reaction can take place at room temperature, in fact. Okay. Now the thing is that BrBr, this bromine is brown actually. Okay. This bromine is brown in color. All right. And this this compound in which bromine is now attached, right? This compound is actually colorless. This compound is actually colorless. How did the brown bromine become a colorless compound? Because of presence of carbon-carbon double bond. Because of presence of carbon-carbon double bond. ठीक है? तो now, because of presence of carbon-carbon double bond, bromine turns from brown to colorless. This can be used to identify carbon-carbon double bonds forever now. So whenever you want to identify whether a compound is alkene, there are multiple ways of asking it. Whenever you want to identify whether a compound is alkene, the question goes like this. Question can say, describe presence of alkene. Describe a test for presence of carbon-carbon double bond. Describe a test for presence of unsaturated carbons. All right. Describe a test for unsaturation. So all these mean the same thing. All these mean the same thing. The test is very simple. The test is very simple. The test is add bromine water. What is the test? Add bromine water to unknown sample. If you want to write the test is very simple. Just write the test. Add bromine water to unknown sample. All right. Add bromine water to unknown sample. All right. So when you add bromine water to unknown sample, if unsaturated carbons were present, if carbon-carbon double bond was present, if the compound was an alkene, then the color of bromine will change from brown to colorless. The color of solution will change from brown to colorless. ठीक है? So that is a chemical test for alkenes. The test is bromination. All right. The test is also called decolorization of bromine. The test is also called decolorization of bromine. All right, it is also regarded to as decolorization of bromine. So that is also a term that you should be familiar of. Now, next, addition polymerization. Addition polymerization is when at high temperature or pressure and in presence of catalyst, alkenes combine together and form polyalkenes. All right, addition polymerization. We will study this further in macromolecules or as well. But addition polymerization is also a type of polymerization in which many alkene molecules join with one another to form one single long chain of a polyalkene. Poly, if you remember from your previous chapters, means many. So when many alkenes join, they form polyalkene. When many alkenes join, they form polyalkene and basically resembles thousands and thousands of molecules. All right, high temperature, pressure, and catalyst converts it into polyethene. Polyethene, which is also famous for plastic. All right, so you can also write. I will write it on this side. Okay, addition polymerization is the main addition polymerization is the main reaction which produces a plethora of plastics. All right, all the types of plastics that we know of, polyethylene, low density polyethylene, high density polyethylene, polyvinyl chloride, polychloroethylene. Okay, these plastics, all of them, they are all made addition polymerization. All right, so majority of the plastics that are made in this world are made by addition polymerization. Are made by addition polymerization. Okay. Um, Now moving on to next, which is production of alkenes. Alkenes, how we can produce them is very simple. Alkenes can be produced by cracking. Cracking was explained very deeply in the previous chapter as the chemical reaction of alkene. All right. So one family's reaction is another family's way of production. So for your IGCSE or O level chemistry and for your further higher educational chemistry, meaning specifically A level chemistry, you need to know for every homologous family two things. What are the two things? Their chemical reactions and the way we can produce them. For example, if you're studying the homologous family, we need to know the type of chemical reactions that alcohols can do, and we need to know the types of reactions with which alcohols can be produced, meaning how can we produce alcohols and how can we react alcohols, how can we produce a homologous family, how can we react a homologous family. these are the two things you need to know of as a O level or IGCSE student or A level student. ठीक है, सही है, अच्छा. Now, with that being said, cracking is very simple. It is breakdown of large alkanes into smaller alkanes and alkenes. All right, that way we can produce alkenes. It was very simple. And with that, the chapter alkenes is completed. Alkenes is this one. Now we to alcohols. All right, we to what alcohols are. Alcohols are organic compound which contain the hydroxy functional group. Alcohols cannot be called hydrocarbons because they contain oxygen. Hydrocarbons are compounds which contain carbon and oxygen, sorry, carbon and hydrogen only. All right. Alkanes can be or cannot be saturated. Mostly the alcohol, sorry, alcohols की बात हो रही है. Alcohols can be or cannot be saturated, but for the most part, the alcohols that we study are 100% saturated. All right, the alcohols that we usually study and the general formula that we follow of alcohols, they are all alcohols which are saturated. Okay, so the famous alcohols are methanol, ethanol, propanol, pentanol, hexanol, etc. Their general form is formula is 1OH or CnH2nO2, CnH2n plus 2O. ठीक है, these are both ways of writing the general formula. However, this one is more preferred universally because it also symbolizes or signifies the functional group of alcohol simultaneously. ठीक है, the physical properties are the same as the ones of alkanes or alkenes. However, just one property is different. We know that alcohols, because of the presence of this oxygen now, because of the presence of this oxygen, are going to be slightly non-polar, मतलब slightly polar now. ठीक है, because of the presence of this oxygen, they are going to be polar now. ठीक है, and when something is polar, it dissolves in water. Therefore, alcohols have a tendency to dissolve in water. They are soluble in water. Now, because alcohols are soluble in water, they can dissolve in water. This means that we can talk about their solubility, and solubility of alcohols decreases when the molecular size increases. When molecular size increases, their solubility decreases. Okay, so solubility of alcohol decreases with increase in molecular size. So let's talk about their chemical properties. Alcohols, just like also undergo combustion reaction. Alcohols, just like alkenes, also undergo combustion reactions. What are combustion reactions? Burning in presence of oxygen, yeah, burning in presence of very little amount of oxygen. Both combustion reactions should be known. Complete combustion produces carbon dioxide. It is happening in presence of excess amount of oxygen. Incomplete combustion produces carbon monoxide. It is happening in limited quantity of oxygen or scarcity of oxygen or when oxygen supplies are diminishing. Okay. Now, the second type of chemical reaction of alcohols is oxidation reaction. The second type of chemical reaction of alcohols is oxidation reaction. Now, what are oxidation reaction? Addition of oxygen into alcohol. Addition of oxygen in molecule or strong KMNO4 and the KMNO dies the alcohol to produce carboxylic acid. सही है, तो alcohols are oxidized to produce corresponding carboxylic acid. Methanol will be oxidized to produce methanoic acid. Ethanol will be oxidized to produce ethanoic acid. Propanol will be oxidized to produce propanoic acid. Butanol will be oxidized to produce butanoic acid. Hexanol will be oxidized to produce hexanoic acid, so on and so forth. Okay, so all these carboxylic acids are produced by the oxidation of alcohol. Basically, alcohol gains in oxygen, reduces to hydrogen. ठीक है, एक ऑक्सीजन गेन करता है, दो हाइड्रोजन रिड्यूस करता है, रिमूव करता है, लूज करता है. ठीक है, the example is very simple. For example, ethanol, when it reacts with oxygen, well, this is not the right way to write oxygen actually, meaning you can write it like this, but for symbols In symbols, you should write it like this. Okay? In symbols, you should always write it like this. Alcohols and then reacting with this. Why do we write oxygen like this for oxidation reactions? Because this oxygen is not O2. O2 is the diatomic molecule found in air. This is the oxygen that is donated from the oxidizing agent. This is the oxygen that is donated from the oxidizing agent. All right. So ethanol produces ethanoic acid and water will also be produced. So oxidation of alcohols produces carboxylic acid and water. All right. All you do is you react oxygen, all right, and you will need two of these oxygens so to balance the equation. If you look at it, everything is now balanced. There were six hydrogens over here. There are 4 plus 2, 6 hydrogens over here, 3 oxygens over here, 1 plus 2, 3 oxygens over here, 2 plus 1. Okay, and everything is completely balanced. So this is the chemical reaction of alcohols. So now if someone asks you, okay, can you differentiate between an alkene and an alcohol using potassium magnate? If someone asks, can you differentiate between an alkene and alcohol using just potassium magnate? The answer is yes, you can differentiate between an alkene and an alcohol by potassium magnate. For at least for O levels or IGCSE students, this concept is 100% viable. In A levels, you will see stuff otherwise, some extra things. But for now, you know that alkenes, they do not react with KMnO4, they do not oxidize under KMnO4, but alkanes, they get oxidized, and when they get oxidized, when alcohols get oxidized, they get oxidized to produce carboxylic acid. So how will we identify which one is alcohol and which one is alkene? Basically, when we add KMnO4 to alcohol, the color of KMnO4 will change from purple to colorless. All right, so that way we can identify that this compound is alcohol. So identification of alcohol can be done, or at least confirmation of alcohol can be done by adding KMnO4 and seeing the color change from purple to colorless. Okay. Now, production of alcohols or production of ethanol, as per se, the more important one is production of ethanol. Why is ethanol so important? Because ethanol has a wide range of uses. All right, ethanol has a lot of uses. Ethanol is a, as you know, ethanol is a solvent. The most important thing is that ethanol is a solvent. Ethanol is also an antiseptic agent. It is used in medicines, antiseptic agent. All right. And then ethanol is also used in beverages. All right. Ethanol is also used in medications. There are a lot of uses of ethanol. All right. Ethanol is also used as a sterilizing agent, but that just basically means antiseptic agent. So these are all uses of ethanol, right? So because they are all uses of ethanol, and ethanol is very important, right? Ethanol is very important sample or substance. Therefore, we specifically talk about ethanol, okay? But we should also know about that this method can produce any sort of alcohol, not the fermentation one, but we can produce any alcohol by hydration method. Fermentation only produces ethanol. Fermentation only produces ethanol. All right. So the first reaction, catalytic addition of steam on ethene, this reaction can produce any form of alcohol. However, when we use ethene, we will get ethanol. If we use propene, we would get propanol. But anyways, this is not used generally. Fermentation method is used. Fermentation method is basically a method that was discovered by the scientist Louis Pasteur. All right. And his process included microorganisms, and the names of those microorganisms were yeast. Yeast, as we now know, is the only unicellular fungus that exists, right? Yeast is the only unicellular fungus that exists, and it is used in a wide variety of food industry products such as bread making, dough making, pizza making, right? Anything that has to rise the dough or enlarge the or increase the size of dough by making the dough rise by producing bubbles inside it. All right. So we use yeast. And on the other hand, we also use yeast where we want to make alcohol, because yeast ferments glucose to produce ethanol and carbon dioxide. So industries which require carbon dioxide use this method for producing carbon dioxide, and industries which require ethanol use this method to produce ethanol. All right. Um, this process, because it has a living organism that is working on it, this process takes place at room temperature and pressure. The only disadvantage of this process is that it produces less pure or impure form of ethanol, which we have to separate out using fractional distillation. All right, so fractional distillation is something very important. We have to separate out all the liquid ethanol that is distilled and collected from over there. Any problems? I hope not. Okay. And with that, our alcohol is also completed. So alcohol is this much. This is alcohol, very small, right? Alcohol and alkenes both are extremely small. Now we move on to carboxylic acid. Carboxylic acid as well is very, very, very small. Okay. Carboxylic acid is not too big either. What is carboxylic acid? It is the family which contains the carboxylic functional group. It's also called the carboxylic functional group or the carboxylic functional group. Okay. Carboxyl functional group is also what it is called. Okay. The functional group is COOH, which looks like this, COOH. All right. So this is carboxyl functional group. You should always remember that carboxylic acids and their functional group. The functional group of carboxylic acid is always located at the corner of a chain. It is located at the end of a chain. Always. Okay. Many examples of carboxylic acid, just like all other families: methanoic acid, ethanoic acid, propanoic acid, buta, penta, hexanoic acids. Okay. Their general formula can be written in two ways. This is to write their molecular formula when writing down their pattern, CnH2nO2. That is their molecular formula. However, the general formula usually we follow this: CnH2n plus 1 COOH, and value of n should be considered 1 less than total number of carbons. For example, if I wanted to write the formula of hexanoic acid, if I wanted to write the formula of hexanoic acid, how would I do that? I know that hexa means n ki value is 6, right? The value of n should be 6, right? So the general formula of hexanoic acid should go like this: CnH2n plus 1 COOH. But what is the rule? The value of n should be considered 1 less than the total number of carbons. And why is that so? Because one carbon is mentioned separately. Therefore, n can only be 5 more carbons. So that 5 plus 1 can be 6 carbons. Hexanoic acid tabhi banega. If this was considered 6, then this whole compound would have been mm, this whole compound would have been uh, uh, heptanoic acid, not hexanoic acid. Okay. So we consider n as 1 less. So therefore, it will become C5H2 times 5 plus 1 COOH. All right, and the final chemical formula will become C5H11 COOH. Okay, I hope this makes sense. Okay, so moving on from this, COOH is the functional group, and COOH is why it is also the acid. All right, so carboxylic acids are acids, pretty obvious, right? They are acids, and therefore they have chemical properties similar to acids as well. First, let's talk about their let's talk about their physical properties. Sorry. Let's talk about their physical properties. We say that their melting and boiling points increases as molecular size and molecular mass increases, just like all other families. Okay? And their viscosity also increases as their size increases, just like all other families. Okay? Talk about their chemical properties. So carboxylic acid have 5 chemical properties. Out of the 5 chemical properties, 4 chemical properties are revision for all my students. Okay? So आप लोगों के लिए सबके लिए this is going to be revision because you studied the chapter called acid bases and oxides, right? We know that carboxylic acids are weak acids, Therefore, they only partially ionize in aqueous solution. So it's carboxylic acid, reversible, irreversible, alkanoate ion, and H positive ion. All right. The second one, they react with reactive metals to produce salt and hydrogen gas. All right. The second type of chemical reaction of carboxylic acid is that react the carboxylic acids. They react with metals, just like all acids react with metals. So acids react with metals and produce salt and hydrogen. Similarly, carboxylic acid, which is ethanoic acid, reacting with sodium produces sodium ethanoate. Acha, beta, you should realize one thing. All carboxylic acid have an H positive ion that they donate when forming a salt, and they have a carboxylate ion. They have a carboxylate ion. It's also called an alkanoate ion. It's also called an alkanoate ion. All right. So it can either be called a carboxylate ion or it can be called an alkanoate ion. Both ways, the basic thing that you need to know of is that whether you call it carboxylate or alkanoate, you should know that the charge on it is -1. The charge on it is -1. It's a -1 charged ion, and because it is an ion and over here salts are being produced, salts are ionic compounds, you need to be able to write their formulas correctly. जैसे कि मिसाल के तौर पे the next is they react with metal carbonates. Acha, look, we've studied that they react with metals to produce salt and hydrogen. All right, so CH3COONA, sodium ethanoate. All right, because ethanoic acid produces ethanoate ion, so it becomes sodium ethanoate. All right, and hydrogen. Now we can also see the same kind of reactions when carboxylic acid react with strong alkalis. All right, so when carboxylic acids they react with strong alkalis, they produce salt and they produce water. All right. So when acid reacts with the base, it produces salt and water. All right. So when sodium hydroxide reacts with CH3COONA, COOH, CH3COONA plus H2O will form. All right. So the metal I prefer to write it at the end. If you want to write it at the start, you can. But why do I write it at the end? It is because the hydrogen, which was at the end, is the one that gets disassociated. No other hydrogen has the tendency or ability to get disassociated. Only one hydrogen can get disassociated. Any problems? Okay. उसके बाद next we have the next kind of reaction is that acids they react metal is things produce acid with a metal carbonate, it would produce magnesium ethanoate, right? It would produce magnesium ethanoate, which percent uh, magnesium plus magnesium has a +2 charge. So this 2 plus 2 goes on the bottom. Okay. And along with that, water and carbon dioxide are also produced. So when carboxylic acid they react with metal carbonates, they produce salt, water, and carbon dioxide. And now the final chemical reaction of carboxylic acid, which is a new chemical reaction. All right, all the other ones, previous ones, you already knew. All right, that carboxylic acid are weak acid, they react with metal, they react with alkali, they react with carbonate. All right, so these were all reactions that you already knew. The reaction that you did not know, however, was the reaction between magnesium carbonate or metal carbonate and carboxylic acid. All right, sorry, the reaction between alcohol and carboxylic acid. All right, and when alcohol and carboxylic acid react, they produce a sweet smelling liquid, and that sweet smelling liquid is called ester along with water. All right, though the sweet smelling liquid that is produced is called ester, and along with ester water is also produced. Because this chemical reaction produces a molecule of water from two different molecules, this reaction is also called condensation reaction. This reaction is also called condensation reaction. All right. So carboxylic acids, they react with alcohols to produce esters. All right, and the names of esters and such will be discussed in the chapters ester. Okay, after this we have esters, which we will study in the next class, inshallah ta'ala. For now we can just learn how ethanoic acid can be produced. Okay, so ethanoic acid is a carboxylic acid which is used in vinegar. All right, so 96% diluted vinegar जो है, ethanoic acid. Basically 4% concentration ethanoic acid is used in strong vinegars, all right, and vinegar is basically a flavoring souring agent, all right. It is used in food industry quite commonly, quite famously, ठीक है. So ethanoic acid is basically the main ingredient of vinegar, which is used in its diluted form. Therefore, it is of high significance. It can be produced by any one of two reactions. So two of the one reactions can be used for the production of ethanoic acid. Now, this one from ethanol, we already studied it in the alcohol chapter, that alcohols get oxidized to produce carboxylic acid. So if we oxidize ethanol using an oxidizing agent, we can produce ethanoic and acid and water. However, the oxidizing agent and heat are expenses that we don't want to bear. So what do? We hire some bacteria for free, and we tell the bacteria, you go and oxidize the ethanol. The bacteria oxidizes ethanol, gains energy while oxidizing ethanol. So bacteria का अपना फायदा हो गया, and the ethanol is converted into ethanoic acid that way. ठीक है, so ethanol is converted into ethanoic acid that way, and ethanoic acid is used in vinegar industry. All right. And with that, the chapter of carboxylic acids is also completed. So we have completed three chapters: alkenes, alcohols, and carboxylic acids today.